Welcome, ladies and gentlemen. This is a short video on solving trig equations for exact solutions, specifically looking at steps we can take to do this. So know that some of these steps have a lot of sub-steps, and we'll see that in just a second, but overall our goal is to use algebra and FTIs so they have a single trig expression in the equation. And so what that means as far as like single trig expression, we're talking about cosine, sine, or tangent. You can also have secant, cosecant, and cotangent in there, but remember on our unit circle we don't actually have anything that shows sine or cosecant, secant, and cotangent. You can always take the reciprocals, but if that confuses you, just stick with trying to get cosine, sine, and tangent in there. Then we use inverse trig operations to get x by itself, so that's where you're seeing your arc cosine, arc sine, arc tangent. And then use our friend the unit circle to find the exact solution. So I thought we'd start with one that's pretty basic, and then we would go on to one that's a little bit more complicated. So let's take a look at the equation 2 sine x equals square root of 3. Okay, first use algebra and FTI so you have a single trig expression. Right away I'm noticing that I only have a single type of trig expression. It's not like we have tangents and sines and cosines all in there, we just have one. So then we use algebra. We get sine x equals square root of 3 divided by 2. Since that is what we did to get x by itself, we divide by 2. So that is step number 1. Then we use inverse trig operations to get x by itself. So we take arc sine, which is sine inverse of sine x, equals sine inverse of square root of 3 over 2. Because sine and inverse sine undo each other, we get x on the left hand of the equation. And then on the right hand side, we just get sine inverse square root of 3 over 2. So remember that when we have inverse functions for trig, our output is going to be a angle measurement. So this is asking us for what angle has a sine of square root of 3 over 2. So then I go to my handy dandy unit circle, which I'm going to bring up here. I say, okay, well, as I'm looking around this, I know cosine is my x values and sine is my y. So the first time I run into square root of 3 over 2 is right here at pi over 3. So keep going around. Oh, look, here's another one at 2 pi over 3. That's good. And that, x, y, nope, those are all negative. Those are the only two. So I know two of my solutions are going to be pi over 3 equals pi over 3. And the other one is going to be 2 pi over 3. So those are two of my solutions. Now I just need to remember that often we have more than one solution for these because they're periodic functions. So if I take a look at this, I can start at pi over 3 and go all the way around in the circle until I get back there again, and that's a new degree measurement. It's going to be 2 pi plus pi over 3. I can do it again and again. And so that's where our equation comes from for all solutions involving pi over 3. So you get pi over 3 plus 2 pi n for all of those solutions, for every time we go around in a circle. X equals, sorry, this is a little messy. Alright, and then we've got 2 pi over 3. Once again, we can start here at 2 pi over 3 and go around the complete circle in intervals of 2 pi n. So our other solution is going to be x equals 2 pi over 3 plus 2 pi n. And those are all of our solutions. So that was pretty easy. The first step on this was a lot shorter than it usually is. So we're going to take a look at a very complicated, or a more complicated one next. Alright, so let me figure out how to insert a new slide. Alright, so now we've got our new slide here. Our next problem we're going to take a look at is cosine x plus sine x times tangent x equals 2. So our first step, remember, was to use algebra and FTIs to get this to be one trig expression. So this time I have 3 different trig expressions in there that I'm going to have to try to condense. So the first thing I'm going to do is rewrite these all as sines and cosines. So this is where some of our sense comes in, or intuition comes in for these. Because right now I'm going to see that I can rewrite this as cosine x plus sine x times sine over cosine, because that is one of our trig identities. And that still equals 2. So now when I multiply this across, I still get cosine x, haven't done anything with that yet, plus sine times sine, because we multiply across, so we get sine squared over cosine x. So right now I'm feeling pretty good about myself because I'm noticing that I have something squared in the numerator, and I have cosine that's all by itself over here. So if we find a common denominator here, we're going to get a Pythagorean identity that's going to look really nice. So again, I didn't necessarily know this going into it. It was just some intuition. So now we're going to multiply the cosine by cosine over cosine, which is the same as 1. So I get cosine x over cosine x, which is the same as 1. Remember, anything over itself is 1, times cosine x, which is coming from up here. So this is our cosine x, just multiplying that out. And just because we have a 1 here, we don't need to do it to everything. It's just multiplying by 1. We're just making cosine x look different. And then we still have plus sine squared x over cosine x equals 2. Alright, so now I can multiply this out. I get cosine x squared on the numerator, all over cosine, plus sine squared x over cosine. We already have our common denominators, so we can add these two together straight across. We get sine squared plus cosine squared. So imagine this with me. We have sine squared plus cosine squared. That's a Pythagorean identity. That turns into 1. In our denominator, we just have cosine. So 1 over cosine x equals 2. Alright, so remember we're still on step number 1. We have a little bit more to go. I'm going to continue this up in this corner. So if I have cosine x 1 over cosine x equals 2, I can multiply that out. So I get 1 equals 2 times cosine x. Oops, cosine x. Ooh, that's messy. Divide by 2, I get 1/2 equals cosine x. Okay, now we're in business. We finished step 1. Now this is messy, but we're almost there. We take inverse cosine of both sides, so we get cosine -1, which is really just inverse cosine of 1/2, equals inverse cosine times cosine, or inverse cosine of cosine, I should say. Cosine x. Alright. Remember, our inverse cosines undo each other, so we just get x on this side. On the other side, we still have inverse cosine of 1/2. So now I should be asking myself, remember this this inverse cosine is going to give us an angle. We want to know what angle has a cosine of 1/2. So now I'm going to try to insert a photo that I've already taken of the unit circle. I'll make that a little smaller. So I've got my unit circle here. I want to know where cosine of what angle is 1/2. So I'm taking a look at this and I'm looking at my x values. It looks like I have an x value here at pi/3. Still looking for x values that are 1/2, and here's another one at 5 pi/3. So those are two of my answers. So I've got pi/3 and 5 pi/3. Same thing as what we saw on the other slide. These are just two of our answers within the interval of 0 to 2 pi. We need to be able to find all of the answers as well. So if we were to add intervals of 2 pi to this, we'd keep coming back to that x value. So then our total solutions are going to be in intervals of 2 pi. So our final answer is going to be x equals pi/3 plus 2 pi n, and x equals 5 pi/3 plus 2 pi n. And then we are done. All right, everyone, good luck.